All right, everyone. I'm here with Eric Rice. Eric is an associate professor at the University of Southern California and co-director of the USC Center for Artificial Intelligence in Society. Eric, welcome to the TWiML AI podcast.
Oh, thank you very much. It's a pleasure to be here.
Hey, I'm really looking forward to digging into our conversation. Before we do, I'd love to have you share a little bit about your background. You are a social scientist, but you work extensively with the AI community. Tell us a little bit about how that came to be.
Oh God, yeah, sure. As if that's a quick story, but I'll try to make it a quick one. So yes, I am a social scientist. I'm a sociologist by training, and I'm a professor in the Suzanne Dvorak Peck School of Social Work at USC. So I've been an applied social scientist working in social work for about 12 years. And I started working with computer scientists back in 2014, and my initial collaboration was with Milind Tambe, who I know you've had on this podcast in the past. And really, he and I met at a kind of a meet and greet for faculty across schools, and I think and when he and I started talking, we realized that surprisingly, we shared an interest in social network influence problems, which I didn't realize that computer scientists were interested in it at all. But then it turns out that they are, especially in the context of Twitter networks and even in sort of modeling other sorts of networks, because the interesting computational problems that go along with it. And I was a social network researcher since the 90s, really, when I was originally trained in sociology. And so I had been working on some projects around social influence in youth experiencing homelessness and HIV prevention. And so when he and I started talking, we got all excited about this very odd, connection that we didn't expect to have. And then when we decided to start meeting together, things quickly seemed very promising. And so we started playing around, and it became a paper, and then a paper became a grant, and then a grant became a center. And the next thing I know, I wake up and people expect me to say intelligent things about AI, and I am not a computer scientist, right? So I mean, I hang out. I've got a lot of friends that are computer scientists, but I am not one. I mean, the last time I took a computer science class, it was 1994, and I was learning Pascal. Right. So just to give you a sense of like what a dinosaur, my computer science is personally.
That's awesome. Pascal's a great language.
Sure. I mean, I don't think I could code a word in it anymore, but yeah, it was cool when I was in college. Yeah, but I was a math nerd. I mean, when I first started college, I thought I was going to be. I started off as a math major, and I took sort of as much math as the folks that do economics and physics do, just because I liked it, and it was like math was an easy A for me. So it's like a couple years of math as electives was what I did, even though I was a sociology major, just because I liked it. But I was really much more drawn, I think, intellectually to social science and issues of inequality and poverty. I mean, I was at the University of Chicago as an undergraduate in the South Side of Chicago in the early 90s, and it was a really race relations were really tense. Poverty was really extreme. And the University of Chicago has a great kind of history of doing sociology. And so it was really hard not to get kind of drawn into this. And then as time went on, I realized that what I was really interested in was these very applied version of social sciences, which is what you get in social work, where people are really interested in intervention work. And then all of that is sort of to say that I become the domain expert. Right. I mean, so I hang out with folks and talk to them about social problems, and then we try to come up with algorithmic solutions to make a difference. Is kind of like a high level of where I'm at.
Awesome. And you recently participated in a workshop at ICLR, iClear, on responsible AI. Tell me a little bit about that workshop, the focus there, and your
Sure.
experiences.
Yeah, I've been very fortunate that the computer science community has been very gracious and welcoming of me. I mean, I'm surprised pleasantly when I hear people talk about the value of working with social scientists and the value of social science, like social work. And I always am like, wow, this is weird that people in this room would say such a thing. But but it's really gratifying. And so I was this responsible AI workshop was really cool. There were I don't know, about a dozen people that they asked to give half an hour talks, and then they had some panel discussions where we all got to, in groups of about six, kind of riff on ideas with one another. And as usual for me in a computer science convening, I'm the one social scientist in the room, but so I say probably, I don't know, maybe high level interesting things, but maybe in the details like dumb things. But I try my best, and one of the things that I was talking about for myself when they asked me to give a talk was really, what have I learned as a social scientist about doing interdisciplinary work? Because that's really been the focus since the beginning with Milind Tambe back in 2014, and now in the center that I run at USC, and the collaborations that I have with people like Phoebe Vianos and Bister Delkina, we still are doing all these interdisciplinary work. And one of the things I was talking about was some lessons learned for me, and I think I'll share this with your audience, because I think that since most folks are, as you said, practitioners in the AI realm, that what I found in working collaboratively is that there's a few lessons that are valuable. I mean, the first is that you actually have to, what I say, like collaborate for real. And that means don't just bring in domain experts and as like a token, or if you're in social science, don't just bring in a machine learning person as a token person and say, hey, run these models. It's like, if you get people together to genuinely work on problems from the get-go, the solutions and the contours of the problem are much more detailed, and the solutions are much more thoughtful and innovative, and it's much better work. The other thing is that you have to learn how to communicate, which is actually really difficult, because in the social sciences and in computer science, there's elaborate professional languages that are very arcane and specific to those disciplines, and they're very jargon filled. And sometimes the same words mean different things, and different words mean the same things. Like, for example, social scientists would talk about variables in the way that a computer scientist would talk about features of a data set.
Mhm.
But when you talk about a variable, you're usually talking about something that's in the level of sort of like an algorithmic level model, whereas that's what we talk about when we're talking about features of a data set. And likewise, like a model, I mean, good Lord, like models mean like 6 different things, because there's like theoretical models, but then theory means something different in social science than it means in computer science. And so you can talk past each other really quickly, even though you think you're speaking the same language, and it takes time to learn to communicate effectively. And
We had a funny example of this just prior to starting the interview.
yeah,
I was describing our audience as practitioners, and to you that was social scientists,
well, no,
social
to me that meant social workers. That meant practicing social workers, like not social scientists who would be,
got it,
running
right,
stats
right,
models, but people that actually work with, a homeless individual and try to get them a house. That's a practitioner, right? And so it's funny because we use the same word to mean 2 totally different
yeah,
things. I mean,
great example of that.
yeah, no, exactly, and it happens all the time, all the time. And it's not insurmountable. It just takes time. And then the last thing is really that you have to iterate, which is part of the process is that as you work collaboratively in these interdisciplinary spaces, the initial solutions may not actually encompass all of the depth of the problem, and that you don't really even realize that you've left things out until you get to the next step down the road. And then you realize that while you've solved one aspect of the problem, new aspects of the problem are emerging and becoming visible to you simply by having solved that first part of the problem. Yeah. So anyway, it's these lessons learned about interdisciplinary work are things that I kind of came across over having done several projects over the years with several different computer scientists, and it's really fun work. I mean, that's the other thing that I hoped I shared with the ICLR. Responsible AI is not only that we can be responsible, and part of being responsible is doing this work in this collaborative interdisciplinary way, but also that it can be a very joyful process. It's fun to, I mean, not that working on problems like HIV and homelessness, like those aren't fun things to talk about, but working with other people that are dedicated to making the world a better place and who want to solve problems and be thoughtful about it can be a very joyful and process. Even though the issues that you're working on can sometimes be really heavy.
Mhm, mhm. I'd love to maybe carry those 3 lessons through as a frame for talking about some of the projects that you've worked on and some of the collaborations. One that you've already mentioned is this work with, homelessness, or this collaboration with Milind Tambe. Um, we talked quite extensively with him about it, but maybe before we jump into something new, maybe the kind of a fresh perspective from your side of the collaboration.
Sure, sure. So when we start, like I was saying a couple minutes ago, part of this started because we realized that we had this surprising shared intellectual interest in how networks can be um, essentially mobilized to with influence maximization as sort of the basis for this. And so, can you pick a set of um, nodes within this network that could be trained? This is in the context of the way that I think about it. That could be trained to disseminate messages that would improve health and well-being in a community. In this case, we
Mhm.
were really interested in youth who are experiencing homelessness and preventing HIV, because almost 1 in 10 youth who are experiencing homelessness have HIV, which is compared to 0.02% of
Mhm.
the housed population. So we're talking, you know, orders of magnitude more HIV risk. And that's because these young people are, they're from very risky backgrounds with where they're coming from very abusive households, lots of substance abuse in those families, substance abuse amongst the young people themselves. They get involved in exchange sex in part to survive, and also they're just having you know sex in sexual relationships with people that are also in risky environments. And so it's just a it's a it's a dangerous from a sexual health standpoint life to live. And but HIV is very preventable if people use condoms, if people get tested for HIV regularly, if you can inform people about some myths and realities about HIV testing. And so that's the sort of the public health goal. But then the challenge is that youth who are experiencing homelessness are really transient. Their relationships come and go very quickly. They themselves are very mobile as a population, so they're kind of hanging out in a specific part of a city for a while, then they move to another part of the city, maybe even to another city. So when you want to spread health information in that community, you have to do it, and you have to do it quickly and efficiently. So therefore, the engineering process becomes really compelling, because can we implement a version of these studies where we can pick the ideal set or nearly ideal set of young people to be that we would work with intensively on a short-term basis, and then they work in their communities to advocate for the health of their friends. And so that project was really exciting. We had some graduate students in computer science who worked on the algorithms. I had some graduate students in social work who worked on developing the actual HIV prevention intervention, training, and how to work with the young people face to face. And we had some successful papers that won awards that students won on the computer science side, projects that got funded and had a lot of visibility on the social work side for my students. And we were lucky enough to get a grant funded by the state of California HIV Research Project. They gave us almost $1 million to do a large scale study, and we actually did uh, 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 an experimental study where we had 714 homeless youth over the course of 2 years that we enrolled in this program, and watched whether or not we could use the AI driven influence maximization peer leader selection process to improve the impact of this intervention. And we did, and it was really gratifying. I mean, I remember the first time that I ran the data after the project we had gotten some the initial data back from the field. And I just sat there shaking my head saying, oh my God, it actually worked. I mean, it's one thing as a social scientist to see these simulation models where,
Mhm.
you can see that, from a mathematical basis that this ought to be more efficient and it ought to have a greater impact. It's another thing to actually see the numbers of real human beings who were impacted be greater when you used those algorithms versus when you didn't. And it was just unbelievably exciting to have that happen. And so, and that really took, in terms of like those three lessons. I mean, it was the social science team, the computer science team, but also the community. So, the young people themselves and three big community agencies that work with homeless youth in Los Angeles worked with us very closely on that project. And it was the collaborations there, the long process of learning to talk to one another and really iterating. I mean, it was the final algorithm that we tested with 700 people was, I think, the fourth or fifth iteration of the influence maximization algorithm. So it was not, we had, some of them were computational solutions that were discarded for improved computational solutions, and some of them were computational solutions that we tested and then said, well, now we've learned a new problem, we need to fix that as well. So here's a new computational solution to an even more complex field problem. So it was really interesting, gratifying work. And and I think the one so I mean, that was kind of how it started, and that's the work that I did with Milind. And then and that was really the project that was the centerpiece really of him and my creating this center at USC back in 2016 in the fall, because we had just gotten funded for that study. We had just gotten, I think the second paper that we'd written with some students in computer science had won an award working on this project. We had some other people that were really getting excited about the work that we were doing, and we decided to create this center with some other faculty and just bring people, our students and faculty together to start working in these interdisciplinary projects. And that's really what I've been doing for the last 5 years, is now just doing social
Nice.
science, computer science hybrid projects.
Nice.
Yeah.
And kind of talking about this idea of learning to communicate in different languages, to what extent did that extend to the different ways that you might approach assessment and measurement in a project like that as a social scientist, versus Millen's approach and the computer science approach of kind of assessing the algorithmic performance of that specific model?
Yeah, no, that's an interesting question. I think so. Computer scientists often get data that is relatively robust data. So, for example, if you're getting click-through rates from web pages, like that data, it's pretty solid data. It's not
Mhm.
messy data. In the social sciences, we often deal with very, very, very messy data because it's collected by human beings from the self-reports of human beings. And if you're interested in, say, studying, youth who are experiencing homelessness over time, you've got to find those people again, right? So there's and you've got to find those people again.
Yeah.
You've got to create situations in which they feel like they can tell you the truth. You've got to create data collection techniques that are in language that those people understand, right? So I mean, it's like, you as an academic may understand a sentence that's got double negatives, but when you are talking to a 18-year-old who is a high school dropout, a double negative sentence may be completely, confusing. I mean, it may not always be, but certainly, you have to deal with this as a reality. And then there's also messiness that I've experienced in working with computer scientists and social scientists together, when we work with community partners and we're trying to use their existing administrative data. So sometimes people get really excited about the fact that social service agencies collect a lot of data on their interactions with their clients over time.
Yep.
And that's a really exciting thing. But the challenge there is that the data is usually entered by social workers who are overworked, who may not necessarily prioritize data entry rigor over, helping somebody find a house, right? And so it's like, oh, at the end of the day, oh yeah, right, I got to enter these things, and I'm trying to remember what it is that I did over the course of the day, and I'll do it tomorrow, kind of thing, and so things get forgotten, things get entered incorrectly, and so there's a lot of uncertainty, which is actually why it's been, for me, one of the things that's been really fun is that as a social scientist, the way that we used to have to deal with uncertainty, or at least the way I used to have to deal with uncertainty, is, okay, I'm going to do some basic statistical modeling, and there's just going to be a lot of error. And at the end of the day, I'm going to have to talk about at the end of my paper what I understand as the complexity of the sources of these errors, like some of the things I just described to you.
Yeah.
But with computer scientists, sometimes they talk about robustness, right? So it's like, okay, well, if we can actually kind of delineate what it is the world of uncertainty is, we can actually try to design some algorithms that are kind of best solutions in spite of the presence of this uncertainty or error, which as a social scientist was mind blowing when I first started talking to them. I was like, but it's really kind of the difference between treating data in sort of this very 20th century kind of way. It's like data as is versus treating data in a much more probabilistic, fuzzy kind of way, which has become much more the realm of data science and computer science. And so it's really exciting. But still, as a social scientist, I think one of the things that I can do is I can help the data science folks to understand what are the sources of messiness in this data that we need to be paying attention to, because and that there are things that I may know from sort of years of collaborating with community partners about the nature of these data that could be helpful, which isn't to say that you couldn't be a very thoughtful data scientist and make a good connection with a community agency and really talk to them in great detail about how they collected their data and what it all means and these sorts of things. But there's sort of I don't know. I think the kind of this triangle, so to speak, of computer science, social science, and community collaborations really is a nice combination of partnerships where there's some real value added by everybody who comes to the table there.
Let's maybe talk about some of the other collaborations and projects you've worked on.
Sure. No, I'd love to. So one of the ones that so first of all, I guess it's one thing to say is that, personally, as an academic, most of my work has been around homelessness over the years. And so while HIV prevention is certainly one of the issues that people face, I've also done a lot of work around housing and housing intervention. And then my center, and I'll come back to the housing interventions in a minute, but the center itself, we've got several areas that we focus in on. So we're interested in what we think of as sort of robust, resilient communities, which is in a sense like planning for disasters, and really the sort of the impact on human populations of global climate change is a big part of this. There's also some work that we've done on conservation as well. But then most of them are a little bit more hardcore social work driven. So it's health and mental health. We're really interested in homelessness is a lot of the work that we do. We have a specific focus on suicide prevention, and we also have a big focus on substance abuse interventions as well, because of some of the other social scientist collaborators that are like, I have a colleague and friend named Jordan Davis who's an expert in substance abuse interventions, and he is he's working in that area, and those are part of our portfolio. And so the two projects that I've been working on, other than the one that I just described with Milind, the most intensely over the last 2 years or last couple of years, has been one in suicide prevention and one in housing allocation. And so
Mhm.
the suicide prevention project is working really on trying to use some machine learning predictive analytics to understand network level interactions between people. I'm really interested in social networks, which is going to come up over and over and over again,
Yeah.
and trying to understand like really who it is that people turn to in times of need when their mental health is really when they're really suffering, and trying to understand if we can do some data mining of network data to try to understand better who might be people that could be eventually intervention allies, kind of in the same way that we thought about the intervention allies in the HIV prevention study. So,
Mhm.
the HIV prevention study had a lot of social science work before I got involved in data mining type of work that led to the eventually the models that we created for interventions. And so likewise, we're doing stuff with suicide prevention. We're working with a couple different populations. There are three actually. One is college students. Another is homeless youth. Again, homeless youth. I'm all about homeless adolescents. And then the third is actually working with folks in the army. And so we actually have a study that we just finished doing the field work on, where we looked at a a battalion who had experienced a very high profile member of their community had died by suicide. And then we were allowed to come in and interview about 250 of these soldiers who had been impacted by this suicide about how they were talking with one another. And so we've got, I don't know, something like, 250 humans and maybe 2,000 connections, and the ways that they're communicating about ideas. And it's really, we've just barely gotten into it, but it should be really, hopefully really impactful to help the folks in the army as well. And so it's like, there's a variety of populations that are impacted by suicide. And unfortunately, actually, since COVID has happened, suicide is up in the United States, and actually, I think across the world. Although I don't know the data very well outside of the United States, and I think that so it's timely to be thinking about these issues. But then the other project that
It's
go
probably
ahead,
worth
yeah.
me jumping in to mention, because I remember going down this path in the conversation with Milind, where
Mm,
every time he said network, I was thinking, oh, okay, so we're mining social network information for relationships. But in fact, that's not typically the case in your work. It's more about using social work techniques to try to understand the implicit networks among the participants in your studies. Is that right?
That's a really good thing to clarify, because I think in the in, most people, when you say networks these days, think about Twitter networks or Instagram networks or
Hmm.
Facebook networks, right? And what I'm talking about usually is, at least in the context of homeless youth, was face-to-face networks of conversation networks that people
Hmm.
have, that are these really, I guess you might think of as implicit networks that you can observe people talking to each other, right? But
Yeah.
there's no I friended you, right, on the
Right.
streets. I'm
Right.
talking to you because you're my friend, but we don't like, there's no formal linkage through a software, right?
Hmm.
And I think the same is true with folks that we're talking about in the army. So you've got, in a sense, when you're looking at people that are in a battalion, in a formal sense, they're all connected, right? Like these
Right.
are, these are platoons that are within, there's like these nested structures, and there's these formal networks, but then there's also informal networks, right? So
Hmm.
not everybody that I work with do I necessarily trust with my deepest, darkest fears and secrets. That's a
Yeah.
subset of people. And when you're talking about people that are, sort of like on base, getting ready to gear up for deployment, which is who the folks that we were talking to were, they're also talking to their spouses if their spouse lives on base with them, their kids if their kids live on base with them, their girlfriends or boyfriends if they've got a girlfriend or boyfriend that's in the community, or frankly friends from high school, or girlfriends or boyfriends that aren't on base and aren't even in the nearby the base, but they're whatever 3,000 miles away in California or something like this. And so, but some of those connections are Facebook, Instagram, Twitter,
Mhm.
Snapchat, whatever. But most of the time when I'm thinking about networks, I'm thinking about them in a more kind of abstract social work sense, which is the sort of sense of like, we're all networked together as human beings. And but how we define those networks is can be very important. And rarely do I do work where we are, say, mining Twitter networks or something like this. I mean, I've got some
Okay.
colleagues that do that work, and it's really cool. There's some really interesting questions to answer there, but
Mhm.
most of the questions that I've been interested in over the years, because of my focus on especially people who are experiencing homelessness who have limited access to technology, right? I mean, it's like most of the people that I've worked with over the years, like they have a cell phone, but oftentimes they don't have any. Their data plan is doesn't work, and so it's kind of like a Wi-Fi device. And so like finding a, it's like, so yeah, they're using social media, but the homeless youth that I'm looking at, they're using it on like a daily basis or a weekly basis, not an hourly basis, the way that you would think about like a young adult who, has a,
Mhm.
the typical 20-year-old in America is like
Right.
glued to their phone, whereas a homeless youth would love to be glued to their phone. They just don't have the resources to be glued to their phone.
And so in terms of this applying machine learning
Mhm.
to these social networks to try to identify and prevent suicide, what's the general approach, and where does machine learning come into play there?
Sure, sure. So what we're doing is that we've collected through some surveys. We ask people to talk to us or to delineate in these surveys the 10 or 20 people that they talk to the most frequently, and then we ask them a battery of, I think it's about 30 or 40 questions about who these people are, the frequency with which you talk to them, what are the means by which you talk to them, what do you talk to them about, what roles do they occupy in your life, things like, if you needed to borrow, $1,000, is there anyone on this network that you could do that from? When you are feeling, if you were feeling yourself suicidal, who would you go and talk? Is there anyone in this network space that you would talk to?
Hmm.
Who did you know before you joined the service? Who on here is a family member? Is there anyone on here that's a romantic partner? How frequently do you talk to each of these people? These sorts of things, and then that becomes a data set that has thousands of dyads, so thousands of relationships that have a lot of information, a lot of features about those relationships. And then rather than approaching it in kind of the traditional social science way, which is to say, well, we a priori hypothesize that these 4 or 5 factors are the things that are important. And so we're going to look at some statistical models and see if those 4 or 5 things are statistically significantly associated with, say, the ability to communicate about suicidal thoughts to a particular person as an outcome. Here we're gonna do some data mining, right? So we'll just do some predictive analytics, right? Like let's just throw in all the features that we've got in the data set, and see what shakes out, and so then it's, and with only a couple of thousand people, yeah, I mean, convolutional neural networks probably aren't going to work, right? But certainly you can do things like decision trees and
Hmm.
random forests, and maybe even some, SVMs or whatever. But even those contributions, thinking about letting the data speak for itself, is not the way that traditionally social scientists have done things. And there are some interesting ways in which, when you're stuck in the world of linear models like logistic regressions, like traditional statistical modeling, social scientists come up with very linear answers to relationships between variables. The nice thing about the way that computer scientists have and data scientists have started to look at things is that sometimes nonlinear combinations of variables are really what's happening in the world. Like, and that is a very interesting new way of thinking about things that social science is, I think, benefiting from in recent years. But yeah, so so that's kind of how we use it. And then the idea would be, especially if we could use if the models are ones that have more transparency to how they work and what the underlying features are, then we can know what are the important features to track over time. And then as we move forward towards thinking about intervention models, you could think about creating small assessments that could then help you very quickly identify people who could be targets of intervention down the road. So who are the types of people that homeless youth need to be having in their networks, cultivating their networks to talk about suicide, or who are the people in these networks of soldiers that people need to talk to, and trying to identify who those people might be. I don't know if that makes sense, but that's kind of the thrust of the ideas.
Mhm. It sounds like the initial phase of the research is to understand these communities and build a model, and then later on you start to experiment with or apply the model to determining which interventions are likely to be the most successful. And they're kind of distinct phases, it sounds like.
Yeah, yeah. I mean, and this is interesting because I think this is something that both engineers and social workers think about a lot. Like there's the
Mhm,
trying to understand the world phase of things, which
mhm,
oftentimes is sort of prediction, right?
mhm.
And then there's the what do we do phase of things,
Yeah.
which oftentimes, I hear computer scientists say prescription is the phrase I've heard like Eric Horowitz say from Microsoft Research say, like here's
Mhm,
prescription, prediction, then prescription. And the way that social scientists think about it is oftentimes when you're looking at like trying to intervene with um, risky communities, you usually think about the first phase of the research is trying to understand what are the risk and protective factors that you could then leverage in your intervention phase of things. And that really basically boils down to prediction and then prescription. And
mhm.
then so it's like, again, language difference, right? But
Yeah.
we're talking about two very analogous, phases of work. And it has been interesting to me how much social work and engineering share in worldviews, even though the techniques are very different. Because in both engineering and this, I think when you and in social work, the idea is to do not necessarily to do science for the sake of science, but it's to do science for the sake of creating solutions to problems. And in the case of social work, it's social problems. In the case of engineering, it can be physical problems as well as social problems. But now my experience with this sort of AI for social good universe is that there's a lot of computer scientists that want to work on social problems, and so we're you know trying, at least I'm trying my best to sort of work with those folks and see what else, what new things can come out of those collaborations.
Great, great. I want to make sure we talk about a third project that you mentioned
Oh
to
yeah.
me. It sounds like, well, it's relating to systemic racism, and I believe it's housing specific. That one.
Yeah, thank you. Gosh, it's like the project I'm most invested in right now, and I almost forgot to talk about it. Phoebe Vianos, who's my partner in this, would kill me. So yeah, so I've got this wonderful project that we're working on. We've got a partnership with the LA Housing Service Authority. I also have a partnership with some people at UCLA in the Semel Institute of Neuropsychiatry, as well as the California Policy Lab. Then people in the School of Engineering at USC. So there's this large group of people. And we've got community partners, and what we're doing there is we are the problem that we're trying to solve is how do we identify people who are in the greatest need for housing resources and make sure that they get the best interventions possible. And the challenge with this is that in a lot of communities like Los Angeles and many other big cities across the country, there are more people who experience homelessness than there are resources to go around, right? So LA, for example, every night has about 60,000 people who are either living in an emergency shelter or on the streets. LA Housing Service Authority placed the most human beings of any community into housing last year relative to anyone's. It was 20,000 people, right?
Mm,
So you can see there's a huge disconnect between
yeah.
the available resources and what's there. So the challenge then is who do you serve? And so one of the thrusts has been to serve people that are considered to be the most vulnerable. And then, so then, okay, that sounds great. Like we don't want people to die on the streets, so
Mhm.
we're going to try to make sure that we get people who need these resources the most into housing. But then the challenge becomes, is this fair? And you can kind of think about this in a few different ways. One is, are the resources allocated fairly? Meaning, if there's 40% of the homeless population in LA that's Black, which is what we have, are 40% of the resources going to Black people? And what we find is the answer to that is yes. But then if you ask the question, are Black people succeeding in those housing allocation as at the same rates? What we're seeing is that the likelihood that people return back to homelessness after getting a housing intervention seems to be higher for Black and Latinx folks than it is for white folks. So then the question is, okay, so we're trying to do this and we're trying to do this fairly, but can we can we can we really do this in a way that is genuinely mitigating a history in the United States of housing inequality that especially the Black communities experience, but also the Latinx community is experiencing. And so what we're trying to do is we're trying to, and the way that this is done is that in most communities in the U.S. they use these triage tools. It's like a survey instrument where we ask about about 40 to 50 questions about terrible things that have happened to you in your life. Like,
Mhm.
have you been arrested? Do you have a substance abuse problem? Do you have health issues like HIV? And on and on and on. Have you been abused?
Various risk factor assessments.
Various risk factors, right?
Yeah.
And then the more of those risk factors that you have, the more vulnerable you are, and the more likely you are then to be served by the scarce housing resources. But there are a couple of different housing resources that most communities have. Some of them are short-term rental subsidies, and others are more long-term programs that have extensive social services and social workers that are attached to them.
Mm.
And so one of the things that Phoebe Vionis and I have been working on, and this is really her area of expertise, is really these resource allocation problems. So given that we have this information about in this case with LA, we've got tens of thousands of people every year that are housed, and we've got this history of information about these risk factors, and then we have a history of information about, did you get a rental subsidy, or did you get what we call permanent supportive housing, which is this more robust form of housing. Then we can look at what are the features of people in the past who've done well in each of those interventions, and then we can see whether or not we can allocate resources differentially, because the current system basically says the highest risk people get the most intensive resources, the medium risk people get the interventions, which is better than nothing. It's thoughtful, but we can do better, right? So and so what we find, especially with the context of people who have experienced a lot of sort of systemic racism and inequality in the housing market, is that when we reallocate resources such that, well, one of the issues is that when you have to do fair machine learning, right? So you don't just want to, if your machine learning is based on a majority white population, but it's inaccurately then characterizing the Black population or the Latinx population, you may actually misallocate people because they don't fit the modal categories, right? So there's those issues that come into play, and then there's issues about just allocating resources differently depending on what people's histories within these systems have been, and so what we're trying to do now is redesign the use of these survey assessments that are these vulnerability assessments to try to serve the communities better. And at least our preliminarily, the computational experiments that we've been working on would suggest that you can do a lot better than what we've done in the past, by both improving the decreasing the bias in the machine learning processes, and then reallocating resources to match people in a more thoughtful way than just kind of really risky gets really good, medium risky gets pretty good. That you can do better than that. So that's the other project that I'm really invested in, and I might have explained it in a much quicker way than the other ones, which is probably unfair to my commitment to it. But I also feel like I kind of rambled on about all of these other ones. So, but yeah, it's really exciting. I mean, the one thing that's really exciting about that project is that because we have this partnership with the LA Housing Service Authority, if we can come up with some viable solutions, we could potentially help thousands of people be allocated to more appropriate resources, which would increase the likelihood that people would succeed in those resources, which would mean potentially that over time, thousands of people will not return to homelessness that would have returned to homelessness. And that seems like a really big deal. And so the social impact of this could be quite large if we do a good job. And it's exciting to get to work on a project like that, frankly.
And what stage are you at with that? Are you just getting started or pretty far along?
So we are we've been working on this for a couple of years. We have a couple of more years in the current grant project that we're working on. I don't know that we'll be done entirely by the time that project is done. It may be one of these things that it kind of becomes something that we work on for a while, because as I said before, iteration is part of the game, right? But we will, there's going to be things in the next year or so that we will be pilot testing with in Los Angeles to see how things work. But kind of larger scale implementation may take longer. I mean, there's also the reality is that there's a huge political process that's involved in all of this as well, because housing is not something that just the federal government provides a lot of this money. Local communities have a huge vested interest in how these resources get done. So even if we come up with a genius engineering / social work solution to this, the community then has to still say like, hey, we think this is important. And part of how we're doing that is that we have a really heavily involved community process. Like, we've got a lot of people that we meet with regularly who themselves have been lived through homelessness, or who are providers of homelessness resources. We work closely with the LA Housing Service Authority. We work closely with the Department of Mental Health, and we talk to all of these people every step of the way, and really get them to help tell us where our blind spots are and how to pivot. Because, like I said before, social scientists may contribute a lot to the dialogue, but also the boots on the ground people who live with this, these issues and with trying to implement solutions also have insights that are valuable. And so we all come together and we're trying the best that we can. And hopefully that'll mean that people will be more eager to try these solutions out. But it's not a foregone conclusion that just a good engineering solution gets implemented. But hopefully this one will. And I think that there's a lot of reason to think that it will, because of the community participation that we have.
Awesome.
Yeah.
Well, Eric, thanks so much for joining us to
Hey,
hear a
thank
bit about
you.
what you're working on. It's very cool stuff.
Well, I really appreciate it. And thanks for inviting me. And it's been a pleasure to meet you, and good luck.
Thanks, Eric.
All right. Thanks.